Hello everyone. Water requirement of crops. Problem session. Session number 2. First problem from GATE 2020. 1 mark. A stream of 200 liter per second is diverted from a canal to irrigate a wheat field in 8 hours. If the runoff from the field is 500 meter cube and the conveyance efficiency is 75%, the application efficiency in percent is, right? We know application efficiency is amount of water stored in root zone upon amount of water delivered to the field into 100, right? Conveyance efficiency, amount of water delivered to the field upon amount of water diverted to the canal system, right? Conveyance efficiency is given 0.75. Amount of water diverted to canal, a stream of 200 liter per second is diverted from a canal to irrigate a wheat field in 8 hours. 200 liter means 10 raised to the power minus 3 meter cube in 8 hours. 8 into 3600 second. Amount of water delivered to the field, right? If the runoff from the field is 500 meter cube, so this is the amount of water delivered to the field. Amount of water stored in the field is equal to delivered to the field minus surface runoff, right? We can easily find application efficiency. So this is 1 mark problem. A stream diverted from canal 200 liter per second, volume of water diverted from canal to conveyance system in 8 hours, 200 into 10 minus 3 into 8 into 3600. Volume of water delivered to the field, volume of water delivered to the field, just 0.75 times this value. Volume of water stored in the root zone delivered to the field minus surface runoff, right? Application efficiency stored in the root zone upon delivered to the field into 100. So 88.4259%, and this is the range provided by GATE. Following the range, it means we'll get 1 mark. A pump discharging water at a rate of 80 liter per second is used to irrigate 2 hectare of the land in 10 hours. पंप जो है ना इरिगेशन के लिए यूज किया जा रहा है, डिस्चार्ज रेट दे दिया गया है, 2 हेक्टेयर लैंड को इरिगेट करना है, आवर्स ऑफ इरिगेशन 10 है. On irrigation, moisture content of the soil on weight basis in the root zone depth of 50 centimeter is increased from 18% to 30%. If bulk density of the soil is 1500 kg per meter cube, water application efficiency in percentage. So जो कुछ भी पूछा जाए आपसे, what is required, just we write water stored in the field upon water delivered to the field into 100, right? We calculate these two amount of water, right? So volume of water delivered to the field 80 liter per second into 10 raised to the minus 3 in meter cube into 10 into 3600. So we'll get total amount of water delivered to the field in meter cube. Now we find net irrigation requirement. On irrigation, moisture content of the soil in the root zone depth of 50 centimeter is increased from 18% to 30%. So net irrigation requirement in order to increase moisture content from 18% to 30% in this root zone depth where apparent specific gravity is bulk density is this, so we can find apparent specific gravity G. So NIR 30 minus 18 upon 100 into depth of root zone into G. So this is bulk density upon density of the water. So this is apparent specific gravity, and we have net irrigation requirement 0.09 meter, right? So volume of the water stored in the root zone, this depth into area, 0.09 into 2 into 10 raised to the power 4. This is volume of water stored in the root zone, right? And delivered to the field is this. So this upon this into 100, this is application efficiency. A field crop is irrigated when the available soil moisture reduces to 60%. So reduction is of 40%. A field crop is irrigated when the available soil water reduces to 60%. Available water reduces to 60%, यानी 60% है अभी. रिडक्शन कितना का हुआ? डिप्लीशन ऑफ अवेलेबल वाटर 40%. This is depletion of available water. Allowable depletion of available water is 40%, right? And then we start irrigation. We are not waiting for complete depletion of available water. We are not waiting for the reachment of moisture content to wilting point. Up to 60%, यहाँ दिया हुआ है 260% डिप्लीशन हमारा एलाउएबल है, मतलब 40% का डिप्लीशन हो रहा है. सो नेट इरिगेशन रिक्वायरमेंट वी कैन इजीली कैलकुलेट 40% of available water. And how to find available water? Field capacity minus wilting point upon 100. If field capacity wilting point are given in percent on weight basis, then we divide by 100 depth of root zone into apparent specific gravity. This is net irrigation requirement in meter, right? The moisture content at the field capacity and wilting point are 32% and 12% respectively. FCWP on moisture content, field capacity and wilting point are given, right? The bulk density of the soil is 1.5 gram per centimeter cube. सो बल्क डेंसिटी गिवन है तो हम मॉइस्चर कंटेंट को वेट बेसिस कंसीडर करेंगे, इसीलिए दिया हुआ है वो. द फील्ड वाटर एप्लीकेशन इफिशिएंसी 75% एंड द crop root zone depth is 50 centimeter. The gross depth of irrigation required to bring soil moisture content to the field capacity in centimeter is very simple problem. Gross depth of irrigation, that is irrigation diverted to conveyance system. This is gross depth of irrigation water, right? So NIR is just depth of water stored in the root zone. So this is very simple problem. First we find net irrigation requirement, and this is 0.06 meter or 6 centimeter. And how to get G from bulk density given in this unit 1.5 gram, that is 10 raised to the power minus 3 kilogram per centimeter cube. 1 centimeter 10 raised to the power minus 2 meter. So 10 raised to the power minus 2 raised to the power 3 meter cube, kg meter cube. Divide this bulk density by density of the water to get apparent specific gravity. So this is your G. G आपका ऐसे निकलेगा 1.5 10 raised to minus 3 upon 1000 10 raised to minus 6. So this is G. This is root zone depth, field capacity, moisture content and field capacity on weight basis. Weight basis term is not given in the problem, but due to ability of bulk density हम ऐसा यूज्यूम करेंगे ये वेट बेसिस दिया है, ये अपना कॉमन सेंस से ये फील करिएगा. सो नेट इरिगेशन रिक्वायरमेंट इज कैलकुलेटेड 6 सेंटीमीटर. Application efficiency is net irrigation requirement upon depth of water delivered to the field, right? Application efficiency 75% and irrigation requirement is 6 centimeters. So depth of water delivered to the field is calculated 8 centimeters, right? The gross depth of irrigation required to bring the soil moisture content to field capacity is equal to depth of water delivered to the field. Because conveyance efficiency is not given, in the absence of conveyance efficiency, we will consider conveyance efficiency is 100%. So depth of water diverted to the conveyance system is equal to depth of water delivered to the field. And here we have calculated depth of water delivered to the field. That is the answer. This is gross depth of irrigation requirement. In a cropped field, the following data are observed. Moisture content and field capacity on weight basis 36%. Moisture, current moisture content on the basis of weight 24%. Bulk density of the soil 1.5 megagram per meter cube. Effective root zone depth 0.8 meter. Conveyance efficiency 80%. Application efficiency 90%. To bring soil moisture content to field capacity, depth of irrigation in mm will be. Depth of water diverted to conveyance system is actually required. To bring soil moisture content to field capacity, the depth of irrigation in mm will be. कौन सा depth of irrigation भाई, जो रिवर और रिजर्वायर से डाइवर्ट किया है कन्वेयंस सिस्टम में, वो कैलकुलेट करना है, राइट? So dear students, we write overall efficiency. Overall efficiency is water stored in the field, that is net irrigation requirement upon amount of water or depth of water diverted to conveyance system, right? So क्वेश्चन में आपको रिक्वायर्ड है कि कन्वेयंस सिस्टम को जो डाइवर्ट किया, दैट इज द डेप्थ ऑफ इरिगेशन वाटर, वो क्या आ जाएगा? नेट इरिगेशन रिक्वायरमेंट अपॉन ओवरऑल इफिशियंसी. नेट इरिगेशन रिक्वायरमेंट in order to bring soil moisture content and field capacity from current moisture content of 24%. So 36 minus 24 upon 100 into depth of root zone 0.8 meter into G. Here bulk density is given, so from this we can find G 1.5 megagram 10 raised to the power 3 kilogram per meter cube upon 10 raised to power 3 kg per meter cube, density of the water. So this is G used here, and overall efficiency we know. Conveyance efficiency into application efficiency, both are given. Conveyance and application both are given, and I keep their values in decimal. 0.8 into 0.9, यहाँ पर जो है ना आप G कैलकुलेट करोगे, NIR अपॉन 0.8 इंटू 0.9 पुट करोगे, डेप्थ ऑफ इरिगेशन वाटर कैलकुलेट होके आ जाएगा. क्वेश्चन नंबर 5. A 10 hectare field has 1.2 meter deep layer of sandy loam soil underlain by sandy soil up to depth of 5 meter. Area of the field is given. This is sandy loam soil SLS, and its depth is 1.2 meter. Depth of sandy loam soil underlain by sandy soil of depth 5 meter. This is the depth of sandy soil. This is sandy loam soil, and area 10 hectare. Field area is 10 hectare. A pre-irrigation rainfall brings moisture content of the top 0.3 meter layer to its field capacity. Pre-irrigation rainfall. Before irrigation, rainfall brings moisture content of top 0.3 layer to its field capacity. यानी इतना का जो है ना मॉइस्चर कंटेंट फील्ड कैपेसिटी पर है ड्यू टू प्री इरिगेशन रेनफॉल. इरिगेशन से पहले रेनफॉल हुआ है, उसकी वजह से इतना हमारा क्या है फील्ड कैपेसिटी पर मेंटेन है. ओके. रिक्वायर्ड amount of water is stored in 0.3 meter depth of root zone. So this 0.3 meter lies in sandy loam soil. The moisture content of rest of the sandy loam layer remains at permanent wilting point. So before irrigation, moisture content of remaining sandy loam soil जो अब वो कितना है 1.2 माइनस 0.3. सो इस थिकनेस की जो है ना मॉइस्चर कंटेंट अभी भी बिफोर इरिगेशन विल्टिंग पॉइंट पर है. The volumetric moisture content and field capacity and permanent wilting point are 32 and 16% respectively for the sandy loam soil. इसी के बारे में इंफॉर्मेशन दे रही है. The field is irrigated with a stream size of 240 liter per second for 24 hours. Considering the drainage from the sandy loam soil as deep percolation, drainage from the sandy loam soil as deep percolation, application efficiency and deep percolation ratio and percent respectively are. So we have to calculate application efficiency. So 5 meter depth of sandy soil is useless in this problem because there is no information about moisture content of sandy soil. So guys, we eliminate information given about this 5 meter depth of sandy soil because we can't do anything. We can't calculate amount of water required to bring moisture content of this sandy soil to field capacity because its initial pre-irrigation moisture content and field capacity both are absent. For this 1.2 minus 0.3 depth of sandy loam soil, we have everything because remaining soil moisture content is at wilting point before irrigation, and we have to bring its moisture to field capacity. Everything is given about this remaining depth of sandy loam soil. So guys, we will perform everything for this depth. So 5 meter and underlain soil, sandy soil, these are useless information in this problem. ऐसे एलिमिनेट किए जाते हैं डेटा को, ना तो ये 5 मीटर और रटा लगाने वाले स्टूडेंट जो होता है ना 5 मीटर को भी कहीं ना कहीं एडजस्ट करेगा, हो जाएगी तबाही उसके जीवन में. Dear friends, so depth of irrigation required in order to bring the moisture content of remaining thickness of sandy loam soil to field capacity. It's very simple. So field capacity, moisture content and the field capacity of this sandy loam soil 0.32. Permanent wilting because initially before irrigation its moisture content is at permanent wilting point, so 0.32 minus 0.16 into this depth, 1.2 minus 0.3, because moisture contents are given on volume basis, so no need of Z. So this is depth of irrigation required to bring the moisture content of this remaining depth to field capacity. Volume of irrigation required. This is calculated from stream size. नहीं, यहाँ पर required की बात कर रहे हैं ना, required volume of irrigation required, right? So 10 hectare is area of the field, 10 into 10 raised to power 4 into depth of irrigation required. This is the volume of irrigation required in meter cube. Volume of irrigation, stream size 240 liter per second, and we are irrigating this field for 24 hours. So in 24 hours, total amount of water used in irrigation 240 into 10 to the power minus 3 in order to make it in meter cube per second into second, total seconds in 24 hours. This is total volume of irrigation. Volume lost in deep percolation. Volume lost in deep percolation. Dear students, this is the total amount of water delivered to this field, and due to deep percolation, suppose this is the amount of water stored in order to bring its moisture content to field capacity. So volume lost in deep percolation is this minus this. इतना ही केवल वाटर स्टोर हो रही है in order to bring its moisture content to field capacity, so remaining will be deep percolated. So amount of deep percolation is equal to volume of irrigation minus volume stored in the, or volume of irrigation required in root zone. So their difference is amount of deep percolation in meter cube. Now we find application efficiency, volume of water stored, and this is the volume of water delivered to the field, right? This is application efficiency. And deep percolation ratio, this is the volume which is deep percolated, and this is the total amount of irrigation. So guys, here we have deep percolation ratio also. So new term is deep percolation ratio, amount of deep percolation upon amount of water delivered to the field. जिसमें सरफेस रन अप नहीं है, सीपेज नहीं है, और स्टोर के बाद जो अमाउंट गायब हुआ है वो कहाँ गया, डीपर्कुलेशन में गया है. क्वेश्चन नंबर 6, मोस्ट ब्यूटीफुल प्रॉब्लम अनसॉल्व्ड इन द मार्केट. कहीं भी इसके करेक्ट सोल्यूशन मिलने वाले नहीं है. अगर होंगे तो उलझा फुलझा कर जो है ना कुछ भी बना दिया होगा. ऑनलाइन भी एक कोई है, एक सॉल्व किया था इसको, मैंने देखा था उसको. गलत आंसर लाया है. इन कला हमने गेट के रेंज में आंसर जो ना ला दिया. इसका गेट का रेंज दिया हुआ है 1000 टू 1013, उसके बीच में हमारा आया है. और देखे थे ऑनलाइन सॉल्व किया था इसको, फालतू सॉल्व किया है, जो मन में आज बक दिया है सॉल्व कर दिया है. इन अ कनाल कमांड maize crop is grown in an area of 30 hectares. The crop evapotranspiration etc of maize is 840 mm per season. In one season, crop evapotranspiration is 840 mm, and the effective rainfall during the growing season is 20 mm. In this season, total amount of evapotranspiration is 840 mm, and 20 mm is actually coming from rainfall, effective rainfall. It is irrigated with water having salinity of 1.1 decisiemens per meter by surface irrigation method, right? Electrical conductivity of irrigation water is 1.1 decisiemens per meter. It is given. If the leaching efficiency of the field soil is 0.8 and the average soil salinity tolerated by the maize crop for 100% yield is 1.7 decisiemens per meter. So guys, this is electrical conductivity of saturated extract tolerated by crop at 90% or more than 90% crop yield. So we will use ZD Road's first formula in order to find electrical conductivity of drainage water, right? Leaching requirement is equal to depth of drainage water upon depth of irrigation water. Electrical conductivity of irrigation water upon electrical conductivity of drainage water. Electrical conductivity of irrigation water, it is given in the problem. Electrical conductivity of drainage water under this given information 5 times electrical conductivity of saturated extract tolerated by crops at 90% or more than 90% crop yields. So 5 ECE minus electrical conductivity of irrigation water, right? So here ECE is given, ECIW is given 1.1 decisiemens per meter, 1.7 decisiemens per meter. The depth of irrigation water in mm per season required to meet the seasonal evapotranspiration and leaching requirement. Leaching और evapotranspiration नीड दोनों को सेटिस्फाई करने के लिए इरिगेशन वाटर की डेप्थ एक्चुअल में कितनी रिक्वायर्ड होगी, बिकॉज यहाँ पर लीचिंग एफिशिएंसी भी दिया हुआ है. जो भी आप लीचिंग वाटर यूज कर रहे हो, जो भी आप ड्रेनेज वाटर यूज कर रहे हो, टोटल यूटिलाइज नहीं हो रहा है ड्यूटिंग लीचिंग इफिशियंसी. 100% लीचिंग इफिशियंसी नहीं है, सो हमारा ड्रेनेज वाटर जो भी है वो पूरा का पूरा यूटिलाइज नहीं हो रहा है. जो एडिशनल वाटर हमने इरिगेशन वाटर के ओवर ऐड किया है, इरिगेशन वाटर जो हमारा इवोपो ट्रांसपिरेशन में खर्च होता था उसके अलावा भी मैंने वाटर ऐड किया था इन ऑर्डर टू डिजॉल्व एंड ट्रांसपोर्ट साल्ट फ्रॉम द रूट जोन. तो वो पूरा का पूरा वाटर इस्तेमाल नहीं हो रहा है. सो वी हैव टू कैलकुलेट डेप्थ ऑफ इरिगेशन वाटर एक्चुअल. We know it is net irrigation requirement upon 1 minus leaching requirement actual, right? Leaching requirement actual is leaching requirement theoretical upon leaching efficiency, right? Leaching requirement theoretical is equal to this 1.1 into 5 into 1.1 divided by 5 into 1.7 minus 1.1. This is theoretical leaching requirement divided by leaching efficiency. Actual leaching requirement, net irrigation requirement is obvious. 840 per season is crop evapotranspiration, and it's 20 is coming from effective rainfall. So remaining is actually obtained from root zone. So net irrigation requirement 840 minus 20 जो स्टोर कराना है सॉइल के पोर्स में, रूट जोन सॉइल के पोर्स में, 1 माइनस एक्चुअल लीचिंग रिक्वायरमेंट, एंड दिस इज कमिंग, एंड ये फिट बैठ रहा है आपको गेट के रेंज में. क्वेश्चन नंबर 7. A crop grown over an area of 50 hectare can tolerate 5 decisiemens per meter of electrical conductivity in the drainage water. एरिया दे दिया हुआ है और कितना टोलरेट कर सकता है इलेक्ट्रिकल कंडक्टिविटी, सैलिनिटी को, साल्ट कंसंट्रेशन. इलेक्ट्रिकल कंडक्टिविटी इज मेजर ऑफ साल्ट कंसंट्रेशन ऑफ रोड जोन वाटर. क्लियर? So a crop grown over an area of 50 hectare can tolerate 5 decisiemens per meter of electrical conductivity in drainage water. So electrical conductivity of drainage water is given. Drainage water is given 5 decisiemens per meter. The consumptive use of the crop is 1 meter. conjunctive use cu is 1 meter, 30% of which is obtained from the rainfall and remaining is made from irrigation water having electrical conductivity of 2 decisiemens per meter. So conjunctive use आपका 1 meter है, 30% of 1 meter is actually coming from rainfall. So net irrigation requirement, conjunctive use and 30% is coming from rainfall, 0.30 into 1, that is 0.70 meter is actually coming from water stored in the pores of the soil in root zone. So this is net irrigation requirement, that is the amount of water stored in the pores for crops utilization. So this is net irrigation requirement, and electrical conductivity of irrigation water is 2 decisiemens per meter. For efficient crop production, the leaching requirement and the quantity of water that must be drained from the area are. So depth of drainage water, first we will calculate, and by multiplying hectare of the area we will get the volume of drainage water. Dear friends, we know leaching requirement is electrical conductivity of irrigation water upon electrical conductivity of drainage water. Both electrical conductivities are given, and there is no information like 90% or 90% above yield and electrical conductivity of saturated extract. So we will use this formula only. So difference आपको पता चल गया जेडी रोड्स का, दोनों में से formula कब किसको यूज करना है. So this is a leaching requirement 0.4, परसेंटेज में 40% हो गया, राइट. सब ऑप्शन में 40% नहीं है, दो में है, ए एंड सी में. तो इसमें से दोनों में से कौन करेक्ट है? तो 2 फिंगर्स माउथ में इंसर्ट कीजिए, इसको ए बोलिए, इसको बी बोलिए, जिसमें काटिए दर्द ज्यादा होगा बोल दीजिएगा. हम काट के देखते हैं, हमको ए में ज्यादा दर्द हुआ, हम ए टिक लगा के चले जाएंगे. ऐसे भी करते हैं कुछ स्टूडेंट. डेप्थ ऑफ इरिगेशन वाटर, नेट इरिगेशन रिक्वायरमेंट अपॉन 1 माइनस लीचिंग रिक्वायरमेंट. Net irrigation requirement we have calculated 0.7. 1 minus leaching requirement, already leaching requirement is calculated, so it is coming 7/6 meter. Another form of leaching requirement, depth of drainage water upon depth of irrigation water is equal to leaching requirement. So depth of drainage water is leaching requirement into depth of irrigation water, right. Field area into depth of drainage water, this is the volume of drainage water जो ज्वाइन करेगा टाइल ड्रेन को, जो नीचे बिछा के रखा गया है. ड्रेन हुआ साल्ट को लेते हुए जाएगा और जो है ना आउटलेट्स होते हुए बाहर निकल जाएंगे. क्लियर. तो हमारा आंसर ए इंडिकेट कर रहा है. इफ क्रॉप्ड फील्ड नीड्स सब सरफेस ड्रेनेज कंट्रोल सैलिनिटी, द इलेक्ट्रिकल कंडक्टिविटी ऑफ इरिगेशन वाटर इज 1.25 millimoles per centimeter and the irrigation water applied is 5 centimeter, right. The equivalent depth of leachate is 2 centimeter. Equivalent depth of leachate, that is depth of drainage water is actually given 2 centimeter. Electrical conductivity of irrigation water, irrigation depth of irrigation water applied 5 centimeter. The equivalent depth of leachate is this. The electrical conductivity of leachate, electrical conductivity of drainage water is actually required. तो इससे कुछ information आपको आ गया, right. We know guys, depth of drainage water upon depth of irrigation water is equal to electrical conductivity of irrigation water upon electrical conductivity of drainage water, and this is a leaching requirement. Depth of drainage water, depth of irrigation water, electrical conductivity of irrigation water, all are given. So electrical conductivity of drainage water we can calculate very easily. Next problem. Electrical conductivity of saturation extract of the soil is 10 millimole per centimeter. Electrical conductivity of irrigation water is 1.2 millimoles per centimeter. The leaching requirement will be right. So leaching requirement is equal to electrical conductivity of irrigation water upon electrical conductivity of drainage water. From the second form of JD Rod's formula, guys, electrical conductivity of drainage water is 2 times electrical conductivity of saturated extract. If there is no information like salt concentration tolerated by crops for 90% or more than 90% held, so we'll use second formula of JD Rod's. Electrical conductivity of drainage water is equal to 2 times electrical conductivity of saturated extract. Otherwise, we will use 5 times electrical conductivity of saturated extract tolerated by crop for 90% or more than 90% crop yields. 5 times electrical conductivity of saturated extract minus electrical conductivity of irrigation water. तो इसमें हम ये यूज करेंगे एंड 6% आपका आंसर आएगा. क्वेश्चन नंबर 10. The depth of penetrations along the length of border strip at point 30 meter apart were probed. Guys, this is border strip. This is canal and here a stream is diverted to this border strip. So पूरी फुल करके जाती है पानी एक साथ जितना विड्थ होता है बॉर्डर स्ट्रिप में. देखेंगे मेथड ऑफ इरिगेशन. We have one problem in our GATE examination from border strip. We will develop its formula. So पूरी की पूरी जितनी स्ट्रिप की विड्थ होती है उतना विड्थ का हम फ्लो जो है ना स्ट्रीम जो है ना इधर डाइवर्ट करते हैं. क्लियर. सो 30 मीटर डिस्टेंस पर हमारे पास पॉइंट्स है 1 2 3 बहुत सारे पॉइंट है 30 मीटर डिस्टेंस पर. यहाँ पर कितने 1 2 3 4 5. ठीक है. यहाँ डेप्थ ऑफ इरिगेशन एट दिस पॉइंट 2, depth of irrigation at this point 1.9, at this point 1.8, at this point 1.6, and this point 1.5. Depth of irrigation is actually decreasing. Compute the water distribution efficiency or uniformity coefficient. So water distribution efficiency is equal to 1 minus y bar upon d bar, where y bar is, we know, average absolute deviation in the depth of water from average depth of water in the root zone during irrigation. So average depth of the water पहले निकाल लो d bar, simply सबको ऐड करो और नंबर से डिवाइड करो. This is average depth of the water, and now we find average of absolute deviation in the depth of water from average depth of water in the field during irrigation. So 2.0 minus 1.76, its absolute value. Take its positive value. So this modulus is showing we are taking positive value. Plus 1.9 minus 1.76. Actually, we are finding deviation of depth of irrigation from mean depth of irrigation. 1.9 minus 1.76. Similarly, we will calculate all absolute deviations and then take their average. नंबर जितना है 5 से डिवाइड करो. 5 नंबर है 5 से डिवाइड करो एंड दिस इज सो वाटर डिस्ट्रीब्यूशन एफिशिएंसी 1 minus y bar upon d bar. Y bar is this and d bar is this, and it is 90.5%. In order to evaluate irrigation distribution, an irrigator estimates the depth of infiltration in mm are given as the distribution uniformity of irrigation. This is a repeated problem. Right, dear students, add this all depth of irrigation and divide by their numbers. We'll get average depth of irrigation. Now we find deviation in depth of irrigation from this value, average depth of irrigation, absolute deviation, and take the average. Is coming water distribution efficiency 1 minus this value upon this value into 100. The seasonal gross irrigation requirement of vegetable crop grown under shallow water table condition is 25 centimeter. If the effective precipitation is 30 centimeter, seasonal crop evapotranspiration is 50 centimeter, and application efficiency of border irrigation system is 60%. The contribution from the shallow groundwater table will be. Here, shallow groundwater table is mentioned in the problem. It means uh, water table is actually contributing in a root zone, right? Seasonal gross irrigation requirement of the vegetable crop grown under shallow water table is 25 centimeter. This is gross irrigation requirement. There is no information about conveyance loss. There is no information regarding application loss. ठीक है, एप्लीकेशन लॉस के बारे में भी कोई इंफॉर्मेशन नहीं है. सो जो कुछ भी हम डाइवर्ट किए हैं कनाल सिस्टम में वो पूरी की पूरी फील्ड में आ रही है. ठीक है, वो किस लिए आ रही है? नेट इरिगेशन रिक्वायरमेंट को सेटिस्फाई करने के लिए. सो नेट इरिगेशन, अच्छा एप्लीकेशन इफिशिएंसी दिया है ना, application efficiency is given, right? Application efficiency is given. So net irrigation requirement is equal to field irrigation requirement, and field irrigation requirement is equal to gross irrigation requirement, because here we will consider 100% conveyance efficiency in the absence of its value. 100% हम consider करेंगे. So gross irrigation requirement is equal to field irrigation requirement, because we are considering 100% efficient conveyance system. With the help of application efficiency from the field irrigation requirement, we can calculate net irrigation requirement. So net irrigation requirement is equal to field irrigation requirement into application efficiency. Field irrigation requirement is equal to gross irrigation requirement. Gross irrigation requirement 25 centimeter, application efficiency 60%. This is net irrigation requirement, and net irrigation requirement is equal to evapotranspiration minus effective rainfall plus soil profile contribution. So guys, soil profile contribution we can calculate. In a crop field, the following data were observed. Moisture content and field capacity on wet basis 36%, current moisture content on wet basis 24%, bulk density of the soil 1.5 megagram per meter cube, root zone depth 0.8 meter, conveyance efficiency 80%, application efficiency 90%. To bring the soil moisture to field capacity, the depth of irrigation in mm will be. First, we find net irrigation requirement to bring the moisture content from current moisture content to field capacity, right? So current moisture content 24%, and in order to bring this moisture content to field capacity 36, and this is G, and this is root zone depth. So net irrigation requirement is this. We know net irrigation requirement upon field irrigation requirement is equal to application efficiency. So field irrigation requirement is equal to net irrigation requirement upon application efficiency. So this is field irrigation requirement, right? Conveyance efficiency is equal to field water requirement, field irrigation requirement upon gross irrigation requirement, right? So gross irrigation requirement is equal to field irrigation requirement or field water requirement upon conveyance efficiency. Guys, this is your answer. A soil has field capacity of 25%, permanent wilting point 11%, and the apparent specific gravity 1.6. Irrigation is applied after depletion of 40% of the available moisture to a crop with root zone depth of 600 mm. Okay, so irrigation is applied after depletion of 40% of the available water. So wilting point, field capacity, both are given, so we can calculate available water depth, field capacity minus wilting point upon 100 into depth of root zone into a specific apparent specific gravity. So this is available water, right? Depletion of available water is only 40% of its value, right? So net irrigation requirement is 40% of this value. This is net irrigation requirement, right? We read next information. Electrical conductivity of saturation extract of the soil is 10 millimoles per centimeter, and that of the irrigation water is 2.5 millimoles per centimeter. Determine the leaching requirement and the total depth of irrigation. total depth of irrigation, leaching requirement and total depth of irrigation. So guys, depth of leaching requirement is electrical conductivity of irrigation water upon electrical conductivity of drainage water, right? In the absence of 90% or more than 90% field information, we use second form of ZE roads in order to find the electrical conductivity of drainage water. So electrical conductivity of drainage water is equal to 2 times electrical conductivity of irrigation water. Leaching requirement, electrical conductivity of irrigation water upon 2 times electrical conductivity of saturated extract, right? It is given in the problem. So this is leaching requirement, and we know depth of irrigation water is equal to net irrigation requirement upon 1 minus leaching requirement. So net irrigation requirement is calculated here, and leaching requirement calculated here. So depth of irrigation water is calculated, and this is last problem. The wheat crop consumes 500 of water per hectare, 500 of water per hectare, and gives a grain yield of 6 ton per hectare. Considering an application efficiency 75 पर the field water use efficiency in kg per hectare per is. अगर ये नहीं भी पूछता तो भी आप इसको केजी में कन्वर्ट करते 6 टन को, तो 6000 kg per hectare is the crop yield in kg per hectare divided by net irrigation requirement into application efficiency. This is field water use efficiency, guys. This is end of water requirement by crops.